Okay. So yeah, we'll start with linked list, and I will teach in C++, and we can change it to C# and stuff like that. That's easy. So basically, linked list is a structure, something like this. So it's a structure like this in which you can store elements or whatever you want to store inside here, and one element has a pointer to the next one. Right? Double linked list is actually easier to manipulate. Linked list makes a very good interview question because, like, at any point if you are at an element, then you can actually always point to only the one. You can only see the one that is next to you. You cannot see what is behind you. If you have a double linked list, it will have something like this, right? So, but single linked lists are more asked in interviews because they make interesting, like double linked list can be solved very easily. So if you think about it, let's say 1, 2, 3 is stored over here. So if you take a node has a value and it has a pointer to another node, right? So for the structure of this linked list, we will write struct. Actually, so when anybody asks you a question in interview, I would want you to write a class. Let's say they ask you a linked list question. I want you to say that, okay, I want to write a class for a linked list, and then I'll write that function, and then I'll do that. What it will do is, like, it will waste your time, like add some more time, and the interviewer will know that you know how to write a class and you know object-oriented stuff and things like that. So let's just write a class. Let's just write the structure first. Structure A list node, and this structure has, we are taking an integer data right now. It can be used as a string, like float or whatever you want. For simplicity's sake, we are taking this. And then next it has a list node star next. So that is the structure for the linked list. Okay. So let's start writing the class for that linked list.
Sorry, what does it say? Initiate
a list node. Sorry.
What's under after int?
Int data and
Okay,
a list node. Yeah, my handwriting is horrible.
No worries.
A list node star next. Okay. So let's write a class of linked list. So class A linked list, and I will send this. So if you don't want to write it, I can send it. Yeah.
You're really gonna send this out?
Yeah. I will. Okay. So we'll take public, and public will have a constructor. So a linked list, and a destructor a linked list. And the destructor should call a function which will actually delete the entire list. So we'll call that void delete list. Okay. So, and I assume you know constructor, destructor. You know. Okay. So whenever you actually make a class and you instantiate a class, let's say I have to instantiate this class. Okay. So I will say a linked list star list is equal to new a linked list. As soon as you say new in C++, what happens, or in C# also, what happens is it will actually go to the constructor and perform those functions, whatever is written in that constructor.
Okay.
So as soon as you say new, and when you are done using this list, you will say delete list. When you say delete, it's a keyword. When you say delete list, it will go to the destructor, and then it will do all the memory management stuff and delete that entire linked list.
Got it.
And that is why in the destructor we will call the function delete list, which will go ahead and delete everything from there. So over here what is happening is I'm creating a linked list, a pointer. So a new linked list is being created and a pointer points to that new linked
The
list.
star list is required.
It's not required. If you don't want to use it, you cannot use it, but that's generally how you write it. I always write like
The
this.
star.
Yeah. So, okay. So we'll have a delete list, and we want some basic functions like add head, add to the tail, get the length of the thing, and stuff like that. So we'll say void add head integer data. This will add to the head of that, and void add tail integer data. This will add to the tail, and let's write another function integer get length. This will get the length of the entire list. Okay. Did I write anything? Yeah. Okay. In the private section, so if you see a linked list is like this. 1, 2, 3. So for accessing this linked list, we actually need head of this linked list, because like otherwise if we are here, we cannot go back and see one. So we need access to the head of this linked list. So what we'll do is we'll make a list node star head, and this will point to the head, so we can access the linked list. Okay, this is basic enough. Like we will go from here.
So, I think
Yes.
you said like when we asked for the linked list, so you said like we will write some
Yeah.
basic things. So how
Yeah.
much we should write for that?
Don't write that one, just the constructor, destructor, and the function that he asks you, and this.
Okay.
That's it. Let's say he asks you find the head of the circular linked list and stuff like that. So you'll say constructor, destructor, head, and then write one function. That's it. Okay. Okay. So let's start writing the linked list. So a linked list colon a linked list. So how you write a constructor? How you write a constructor is always the constructor is always the same name as the class name, and the destructor is also always the same name as the class name. It has a tilde in front of it. C++. Not in C. No, C sharp and destructor. There is no destructor. There is.
Not mirrored.
Not
It's
in
not
default,
it's
it's
not.
not. But it's there and it's managed, but you can run it.
Oh,
Hardly people use that.
I've been writing. I write C sharp, but I'm not that much.
No problem.
Yeah. Okay. So in linked list, the constructor, all we need to do is initialize the head to null, and we'll say head is equal to null. Right? That's all we need to do. For the destructor, a link list colon tilde a link list. We will call a function called delete list. Okay. I will erase this part. And I press. Now erase this part, and we will write the delete function. So void a link list colon delete. Okay. So how we will do it is 1, 2, 3. This is pointing to head. We can't simply delete the head, because if we delete the head, we will lose everything. So what we do is we actually point a temporary variable to the head, and then we'll say head is equal to head arrow next, and then we delete this. and then we continue doing this till head becomes equal to null. Pretty simple function. So I will write this and another function, and then after that you guys will start telling me how to write the other simple function. These are very simple things. Okay, so a list node. First we'll check if head is null. If head is null, you just return. So, if not head, return. Okay. Otherwise, we'll check a list node star temp is equal to head. So we pointed that to the head. Now what we will do is we will check while head while head exists, what we are going to do is head is equal to head arrow next. Head is equal to head arrow next, and delete temp, and temp is equal to head. Yes? Yes, second. Right? So first we'll check, then we'll have a temporary variable pointed to head. We'll check while head exists. We'll say head is equal to head arrow next. We'll delete the temp and make temp is equal to head. This will continue. At one point head will start pointing to null. We'll come out, the entire list is deleted. Yes? Okay. Let's do, so what was the other function? Add to the head. So how are we going to, I will, if you do not understand, stop me. I want to get to the basic functions fast so that we can do the other questions which I asked in the interview. Okay, so how if I want to add, let's say 1, 2, 3, if I want to add a node in the starting, what we will do is we'll create a new node. We will point it to null. Assign, let's say we want to add 0, assign 0 to it. Then we'll check if head exists. If head does not exist, then we'll make head is equal to this one. If head exists, then we will actually point this one to head, and then we will change head is equal to the new node that we created. Yes? Easy, simple. Yes? Okay. So, void a link list. It is very quiet, so if you guys can tell me, give a feedback, that would be good.
It all makes sense so far.
Huh?
It all makes sense so far.
It makes sense so far. Good, good. Integer data. Okay. So how do we in C#? I'll send the. I think you made a C# linked list. You sent it to me long time ago. I'll send that one too. Okay. So in C# also it is similar. So how you do it is you actually create a new node. So a list node star add is equal to new a list node. Okay, so I created a new node, and I'll say add arrow data is equal to data, and add arrow next is equal to
No.
null. And then what is and then we will check if not head, which means head does not exist. What we do is head is equal to add node and return. Okay, and otherwise we will say add arrow next is equal to head, and head is equal to add. Yes. Huh? Yes.
understand this, but is add head a commonly used method for linked list?
Which one?
Add head.
So this is basics. You're
This
just
is-
going through basics. But yeah, add head, actually add tail will be frequently used.
Yeah.
Add head usually comes when you're treating it as a stack.
Every time item will be added at the end.
Every time item is
Before the
added
head.
before the head.
Any specific reason to use C++ language?
It's because I'm comfortable. I coded that. That's the only reason.
Linked list, usually when you do linked list, it needs a very clear understanding of pointers and
Yeah,
Right.
C++ handles pointers.
point. So, yes, that's the only reason. I write code in C++ and that's the, oh, I should not have deleted it. I could have used it for the add tail. Okay, so what add tail will be 1, 2, 3. Let's say we want to add 4. We'll create a new node 4, which will point to null. We'll check if head is not existing, then this will become head. Otherwise, we will take a pointer which will point to the head, continue moving that till its next points to null, and then instead of this pointing to null, it will start pointing to 4. So simple. I will write it in very fast, and then I think after that I'll do one is getting the length, and then we'll start. That is also similar to this one, and then we'll start doing the questions which I asked. Link list, colon, add tail, integer, data. Okay. A list node star add is equal to new a list node. Okay. Add arrow data is equal to data. Add arrow next is equal to null. Okay. We will check if not head. Head does not exist. Head is equal to add and return. Okay. Yeah. Otherwise, we will take a temporary variable, a list node star temp is equal to head. So that temporary variable starts pointing to head. Then we'll say while temp arrow next is not equal to null, temp is equal to temp arrow next. So we'll traverse the entire list till temp reaches to the last one, and then we'll say temp arrow next is equal to add, and add arrow next already points to null. So this will be the add tail. Now you guys will change this function and give me get length, and this is an integer. Okay, so yeah.
For that, just wanted to bring your attention to, on the right hand side in delete, he has used a traversal of while head, and on left hand side he has done till while temp next.
Okay.
That these are the two different types of traversal that you use in linked list, depending on where you want to end up. You want to end up at the end of the list or right before the end of the list.
Yes.
Just keep that in mind.
Yes. Okay. So who is doing? Yeah. So you guys tell me how to get the length.
We can use that while loop.
Yes. Yeah. Just change this function. You tell me because I know you know it. Yes.
Sorry. So
this is an integer. So I'll
we
say
can take an integer equal to 0 or 1.
we don't need this because we are not adding anything. If not head, return 0.
Otherwise, we need to take one variable,
Integer
length or something, whatever count,
is equal to
0 or 1, whatever.
okay.
Zero.
There is function.
Just for-
So I count is equal to
0.
0. Okay.
And then remove this while next step. While not temp.
Which one are you talking about?
Yeah, under the while.
This is recorded, so if you don't want to show your face,
That's
I
not a
understand.
problem.
Okay.
You can go inside the while loop.
I can go inside the while loop.
And then
But
inside the braces,
okay,
you can remove this next.
okay.
No, next. Inside the
This way.
inside the while loop.
While
Condition section. Condition section. Go inside the
Oh,
consider
that's
section.
it.
Yeah. Remove this knot. Just like that. While here.
Yeah. Okay.
Yeah. While temp.
While temp.
Yeah. Here it should be temp, right? Because you are traversing through the temp,
Okay.
right? And I count plus plus
I count.
and return.
I count.
Yeah.
Is condition again while temp is not equal to while temp next is not.
Or next is required to traverse to the next road. Temp equal to temp dot next. Temp hyphen next. Yeah. I don't know.
Okay. I think there might be an indexing problem in this where,
Can I change it?
yes,
In while
We don't need even if condition,
yeah.
and you can
I know we don't need the if conditions. I know this.
directly head.
But this gives the interviewer a thing that you will tell them, do all the theatrics and dramatics that, oh.
That also gives you a defensive program.
in while also
You are checking
it means
first
like
and then
temp
you are
next is
moving
not
next.
equal to.
Yeah, that's true.
Yes.
That's very true.
This will break on one condition, which is like given another reference exception, because like in the end when it goes
Yes,
to the
yes,
next
yes,
one.
yes.
So yeah, you guys get the idea. If you do not, everybody, I think most-
Where will be the exception?
यहाँ
When
पर
temp reaches to the null.
temp is equal to temp. अच्छा नहीं
कैसे आएगी?
no, it won't come.
Yeah, it will not,
It will
because
not.
while
Sorry.
will not execute.
Yeah, while it will not. Okay, good. Sorry. Okay. Okay, so we did this. There is a lot of questions that people ask in the interviews, which is just one second. ये है ना?
इसको कहा गया है, इसको सब कुछ तो अच्छा है।
Okay, yeah, we'll see. Okay, so
I
lots
also
of
have a question.
Yes.
So, the thing is, we keep on mentioning head in our functions, but we don't declare head in the structure or make it.
we did declare in the class. In the class, we actually declared in the private section.
Yes, we do.
Yeah,
Sorry.
we declared the private section, and in the constructor, we initialize it to null. Okay. Okay, so we got the length, and let's do. There is a lot of questions which actually are solved by the runner method or something like that. What it is that there is. Let's say there are 20 elements in this, and they asked you to find the second from the last element. So that's called the runner method. I'm not going to waste the time. It's like old thing. So one way to find is find the length of this linked list. Let's say this is 1, 2, 3, 4, 5. So 5, and they said ask you find the second from the last. Then you traverse the list again. And 5 minus 3. So when you traverse the third time, you can actually say that okay, this is the element. So let's say 1, 2, 3, 4, 5. They ask you find the second from the last. First time you can find the length, and then what you can do is length minus 2, which is this, and then you traverse again and find 3. So that is one way to do it. Another way to do it is actually take 2 pointers. a slow and a fast. Oh no, front and back. Okay. And what you do is you actually, if they asked you kth from the last or second from the last, move front 2 times over here,
Position.
and then after that keep moving front and back at the same level. When front reaches null, your back will be at the kth from the last. So there's a lot of questions like delete nth from the last or insert nth from the last or something like that. So people change. So we'll do find kth from the last, and then we'll do insert kth from the last. You can go ahead and do the delete nth from the last. There will be conditions in which, let's say if there are k elements, if it asks you kth from the last and there is fifth from the last and there are just 3 elements. So there will be some conditions that you will point out. So what will be the conditions? Whenever I have taken interview, nobody has actually written down all the conditions. So if you guys can tell me what can be the different conditions, that will actually be helpful. Because if somebody comes to an interview happy and he writes some of the conditions over there and stuff like that, I would be happy. So I would want you to do that. It wastes time and you will gain some time. That is.
Condition for what?
Conditions. What are the different conditions that can happen in this problem?
So just real quick, restating the problem, we're saying that we're solving for
Kth
the k.
from last.
Okay, so let's see. I guess one scenario could be that that k is bigger than the list.
K is greater than length. Okay. Another set can be
K negative value.
K is a negative value.
And head is null.
List is null. And one is a general condition, which you return that value. I think these are the 4 conditions. If you can think of something else, we'll code according to that. Okay. So we will say integer, and we'll ask the interviewer, what are we returning? Are we returning, let's say we are returning integer value, and let's assume that it is positive values, and if we return -1, that means that we didn't find it. Yeah?
Right.
Okay. Okay, so integer a link list colon and okay from last integer k. Okay. So we will check for the condition k is negative if k is less than 0 or less than, I don't know, 0 will be
Last.
no.
Less than 1.
Okay, k is less than 0 or 1? Less than 1. Return -1. Okay, second condition is if
No, if it is 0, like we can return the last element.
Again, that we need to
One-
clarify from
one
interviewer.
that you need to clarify from the interviewer. If list is null, so if not m head return -1, ask your interviewer like what happens if m head is null and k is 0, then you might, I don't know what you want to return. You have to ask the interviewer. Okay. Then what the next step we need to do is front and back. So a list node star front is equal to is equal to head, and a list node star back is equal to head. Now we need to continue moving front k times. So for integer I is equal to 0, I is less than k, k plus plus. You can use a while statement here also.
I plus plus.
Yeah,
I plus
yes. I plus plus. You can use while loop also. I always use for I don't know why.
command over the index.
Yes. So okay. So what are we going to do now?
We are going to move forward.
Move the
Front.
Okay. If and we will need to check
Yeah. It's
Uh,
easier to think now.
if front is not equal to null, which means front has not reached null. Front is equal to front arrow next. Okay.
Else,
Mm,
else k is greater, so return minus 1.
now,
If it is and it's iterating again, that means k is greater than the entire length.
yes. So we have not checked the list, the condition for that, right? Yeah. Tell me the condition for that.
I mean, yeah, we can use this within this problem. We can use the condition within this problem.
Okay. What is the condition we use?
So we can put something like if front keep front dot next. If front keep moving front dot next. Front equal to front dot next. And
Okay.
I mean, we have to write if else. Yeah.
Front is equal to front arrow next.
Yeah, else what are the minus 5 are written.
Else return minus 1.
No.
Yeah.
Yes.
No. Like what happens like if k is equal to it's the entire length of the list.
Yeah, that's why the front is coming, right?
Okay.
Yes.
Okay. So else minus return minus 1. Okay.
So I think we should break in if.
We should break in.
Return
No.
means
No.
There's a k.
We need to check the condition as well for the k.
I would not check the condition is already checked.
Right.
I will be written.
I is greater. So now it has reached.
To the kth position. Yes,
To the
yes,
kth
yes.
position.
Sorry. Yeah.
So now it will come back, and now what we will
But
do
Anish,
is-
how are we handling the situation like when the k is greater than the length?
Yeah, the return
That
minus
is return
else.
one.
Else condition.
Else condition.
If front, okay.
If front, which means that front does, if front exists,
Okay.
then front is equal to front arrow next. We continue to increase that. If front does not exist and it is still less than k, then that means that the length is actually less than, k is actually greater than the length. So in that case, we will return minus 1. Right. After that, what we have to do, while front exists, front is equal to front arrow next,
And
back
back.
is equal to back arrow next. Okay, and in the end we return
Back.
back. So we are returning the back.
Where is it that we put the spacing in between front?
Okay, so let's take example. Let's take an example. One, two, three, four, five. This is the front, this is the back, and k is equal to 2.
Right on.
So it's front is at 1, back is at 1, k is 2.
That's it.
Okay, so we are first over here and we'll put I.
Okay, I got it. So basically the
Yes.
incrementing happens there,
Yeah,
and then it goes into that while,
Yeah.
and then, okay, got it.
yes. Did you guys get it? Yes. Abbas?
Here also we don't need to check head condition because it's gonna check in the forward. We don't need that.
We don't need that, we will just say that these are the conditions. Okay, so we did the care from the last. Let's do insert nth from the last. Insert kth from last.
Sorry, going back to the previous, fine. Done.
Let's run through this.
Yes, please.
Let's just start. Okay, front was here,
Yeah.
back was here. Okay, k is I is equal to 0. Right. Front is equal to front arrow next. Front exists. So front is equal to front arrow next. Front came over here. So front is at 2, back is at 1. K is 2, I is 1. Then
One more.
one more. Front is at 3. Front is at 3. Back is at 1. K is 2. I is 2.
Got it.
We will break out of this loop now. We come over here while front exists. I don't know, there might be an indexing problem. So I'll actually go through it. So 3 and then front will move to 4. Back will move to 2. K is 2. We don't need this anymore. Then front is at 4. Then front is at 5. 3, 5, 3, 2, 1. I think there is an indexing problem. 5. We can say front arrow next. Then that will actually fix it. Yeah? Okay.
So this type of correction in the code we can do in front of the
I
schedule as well.
think we can do
Right?
it in the front. If you write it like this, and you can actually, this shows that you can actually debug the code,
Right.
and you can go through the code.
Because
and
there's a
see.
small mistake anybody can.
Anybody can. The indexing problem, like I do indexing problem every day in like my code. So that is, yes. Okay. Yes, definitely. Okay. So insert the kth. Let's do a delete kth.
Test case is interesting, I think.
Yeah.
Kind of problem.
I'll do the delete kth and then you do the cycle. Yeah, you do the, then you guys do it. You guys tell me how to do the delete kth. So let's say I have a linked list and they ask you to delete the kth element. This is a very similar problem, but requires a little bit different approach.
KS from last or
Kth from last. Kth from last. So what we will do is similar kind of thing, front and back. And so what will be the conditions? First condition is list is null. Okay.
K is greater than length.
K is greater than length. Third condition is
K negative.
K negative cannot be. No, it
K
can.
negative.
It cannot happen.
I mean, like if somebody passes
Apply
a negative value, you can say u int over here.
Then it's
Yeah, then that won't happen. Okay. Fourth would be if they have k is equal to 0, which means they want to delete the tail.
K equal to length.
And k is equal to length, which means they want to delete the
Entire stuff.
the head. Okay.
But how does that K equal to 0 significant that they want to delete it?
from last time.
0th from last, they want to delete the last element.
We will in last example we consider the one.
I'm just listing out
Okay.
I'm just listing out what are the different possibilities. So, can you think of something else? No? Yes. Okay. So what we will do is we will actually I did not study at all. Like I'm just doing it blind, like out of I have not been teaching for a long time, so it's if I do mistake, please correct me. It's not. Okay. So let's check.
We're playing it live.
Huh?
We're playing it
We
live.
are playing it live. We are playing it live. If not head, just return. Okay. Otherwise, what was the second condition? K is negative. That won't happen because we are passing the u int. So this is not going to happen. Okay. K is equal to 0. List is null. K is greater than n. Similar kind of thing. A list node star front is equal to head back is equal to head. Okay. For integer I is equal to 0, I is less than k, I plus plus. What was the condition last time? If front is equal to front arrow next. Okay, else return. Okay. Now we
Or
come.
else we can break as well.
Okay, but we are
Yeah, but
making
better
the-
to return.
Huh.
And otherwise we need to, otherwise execution will move next.
Yeah,
Return is best.
yeah, so we return. Generally, when I write my, like the production code kind of thing, I actually return only at the end of the function. I try to make sure that I don't have multiple returns. But like this is interview stuff, so.
But few people likes to return everywhere. Why
Yeah,
you
yeah, I
check
know.
all the conditions? Unnecessary we are increasing.
I actually never, I never do that. Like I always try to have just one return at one place. That makes it debugging easy.
Mm.
So, anyways, okay. We did that. Then we will check what is the condition. Now, what we'll do is while front, there is actually like, let's say if I have to delete the second from the last, I actually need to go one before that.
Right, because you are doing 0 bits.
Yeah, because like if I cannot actually delete myself. If I delete myself, then like the thing which was pointing me will break. So I need to be one before that. So I think like this should be
Equals, this
Okay,
is
start
So we are if under the if we can
Okay,
say
start from
front dash next.
uh,
Under the if we can mention front hyphen next,
No, we can start from the one index I.
not equal to null.
we can
I
start.
equal to 1.
No.
I
No, no,
equal to
I
one.
less than equal to
Front.
one.
Under the if condition we can mention.
So front is here, back is here.
Mm-hmm.
Front has moved 2 points. Front is over here now.
Mm-hmm.
Back is over here. We will continue to move till front arrow. Last
So
time
that is
front,
coming.
So
while
what are
front
k
arrow-
minus 1?
That will come in
Yeah,
down.
not
side,
equal
right?
to null.
But
We
Next
can-
dot next not equal to
Give me
null.
give me 1 second. Give me 1 second and I will figure it out. If this is the condition. If front arrow next does not exist, which means if not front arrow next, then that means that they are asking us to delete the head. Yes?
No, because in the front we will reach that place.
So at this point, like, okay, let's say this was 5.
I think we can do like this way. I mean, under the if condition, if we mention front arrow next not equal to null, then we will be we will terminate before the second
I
one.
before, yeah. That is all.
Ashish, why not do k minus 1?
We can do that now too.
So then I will say we can do I equal to 1 also.
Let's see
It will
what
be
I had,
same.
let's see what I had written earlier. That I don't want to go into. This,
Yes,
this
that
is
will
a
also
very
work.
this is
Either
a very
here or here.
easy
What are-
easy question. It should not take that long. I should have read this before. Sorry. And I'm doing some I count stuff over here. I'm taking a counter and I'm counting the values and blah blah blah. Anyways, regardless, you guys, I think you guys can figure it out. Yes?
Yeah.
Like, delete the next one. If you cannot figure it out, I will send this code. This is out there. So that is, yes. If somebody asks you a question like this, first ask them, is there a cycle in the list? Always in the linked list, ask if there is a cycle. Because if there is not a cycle, then this will actually go, if there is a cycle, this will go in the
low infinite.
okay. So now Jayashree will teach.
Okay, Ashish, before that. What is the advantage that we get from the front and back? I say like I want to do it through the like first time.
Yeah, you have to traverse 2 times.
So what? It's order of and.
Well, if they are, let's say, people will ask you like, oh, it's 2. Yes, it is order of n, let's say there are a million.
Yeah, even then also it's fine because in that case also like we are going to traverse to like because
We are going to
two
traverse
pointers-
just once. No.
For loop will be one
Yeah.
for a sake, but actually if you will see, we are again going down and again we are going to do the same thing.
No.
No, this is.
This will go-
million plus 2 times you are traversing.
First 2 million.
Yeah,
Yeah, the other one is 2 million.
2 million.
So you can take the one additional space and you can save 1 million iteration, right? With the back.
The worst is
Yeah. No.
and I will check that million and 2 million I will check it. But ultimately it's order of n in both cases.
Ultimately, yes, it is order of n. Yes.
As we are assuming there is a
Yes.
million number.
Why this question is over here is because it was there in programming interview exposed and then it got carried on to the other book and so everybody asks this question. Okay. Yeah, we'll take a 5-minute break. So, yeah.
थोड़ा कंफ्यूजन है ये बंदा पता नहीं ड्रॉप हो चुका है
वो पहले का रिप्लेसमेंट पहले का
यहाँ से चलती है बीच में ब्रेक आता है
Performance, you will get stuck so many times in the app when you open your app. That's the biggest disadvantage.
Seriously, which app?
Windows Phone, I use the Nokia. Okay, we'll start here.
There are a lot of Windows Phone fans here, so
I love
hold your
iPhone.
guns. Hold your guns.
it's recent
That's true. Even though I work for Microsoft, I can.
Android.
But in interview take the Windows phone. In interview take the Windows phone.
Okay.
if you are going
My wife works in Windows Phone.
Okay.
You love Microsoft.
Okay, so reversal equals, this can be done both iteratively and recursively. I'll start out with an iterative function. I'll explain how it works. So usually we start with 3 pointers. One is back, for back is back. This is the middle, and this is the front. So the way it will work is back should start off with null, middle will be here, front will be here, and then we will start moving all these 3 together and reversing each of the 3 by itself in this way. And then by the time we reach the end, the front will be here. At that point in time, everything would have reversed. Does that make sense?
Yes. Yes.
I'll write the code and then we'll walk through it and then it will make more sense.
You will also write in C++, right?
Yep. You're trying for C#? Java.
C#.
Okay.
Yeah,
The good thing about C# is instead of arrow, just use dot next and it will work.
We will practice ourselves on C#, no problem.
So, void reverse this. So first we need to do the basic check if you're not and head. Just return. If the linked list is empty, we'll just return back. Actually, if it has only one, if it has only one node, so you're at that point in time it is already reversed. Okay. So we'll start with back. As I said, it will start off with null. We'll have middle as your head, and we'll have front as and head next. Okay. So this is just the initialization part. Now we'll go in an infinite loop. So this one, middle next, is now pointing to back. So your one is pointing to null. This is your front, this is your middle, this is your back. Okay. Now, if not front, so your front, if it is null, then you just break. This condition will exit us out of the infinite loop. Back equal to middle.
So Jay, why are we not putting it in while loop? While
I'll get to it. Give me one. So your back is now becoming middle. So it is just traversing one ahead. Your middle will become
front.
Front. Your front will become front next. And then when you are out of this, your head is now front. We'll walk through this once. So we have a back, middle, and a front. Start with null. Middle is 1, front is 2. Correct? So now, over here, your middle next should be okay. Your middle is 1. Your middle next is actually 2, your front is 2, and your front next is 3, correct? So when we start here, it will be null. Your middle will become middle still 1, middle next is now null. This is still the same. Now over here, we are again changing it back. So your back is becoming 1, your middle becomes front. So 1 becomes 2, this is still null. No, this will now become 3. Front is becoming front next, so this will become front next. This is 3, and front next will be 4. Correct? So your this over here, this is null. 2 is now your middle. This is your back, and this is your front. Correct? No?
It changed. Okay.
Make sense? You look confused.
No, that's fine. I thought that 4 was a 6 for a second.
Oh, sorry.
Okay. I was like, how did he get to 6? There's not a 6 up
Anyways,
there.
okay, so now we'll come back. Your middle next is now equal to back. So your middle next, so my 2 Who's next will now point to back. So this will point to back. So I will have 1 which has null. My 2 is pointing here, correct? So my middle next is pointing to 1. Back will now become middle. So this, my back is now becoming middle. So this is my back. My middle becomes front. This is my front. And of course my front next. Sorry. Middle. This is my front. This is my front face front next. Correct?
I think the last end head should be equal to middle because we are breaking out if condition is if not front.
Okay. Let me get to
Yeah,
it.
sure.
So now, same thing applies. My 1 is, my 2 will be here. My 3 should now start pointing, instead of 4, it will start pointing to 3 or 2. This is still pointing to 4, this is still pointing to 5, this is still pointing to null. This is my back, this is my middle, this is my front. Next iteration of and now I have my 4. So now middle will start pointing to back. So this will become this. My middle, now this will now become my back. Okay. No, this is going back. This is still middle. And this, my front is now gone.
Front is now down.
Correct?
Yes.
Now, when
Front
I
is
come,
now then phrase.
now, no, before that my middle next will become back. So this is still like this. It will now become and this should be that's why this condition comes after middle next. That makes sense? Now, tricky question. Without reversing a list, print the list in reverse.
I thought you were doing the reversal using recursion or printing.
I'll do
using-
that.
Okay.
For that, print the list without actually reversing the list. Print the list in reverse. So you have one.
Without using any other data structure, right?
Yeah, well, that's key.
Without traversing the list, is that what you said?
No, not without reversing the list, without reversing the
Okay,
list.
that's
Actually
the
the
list.
card. You have to be psychic for that. This is all I want. Without you actually reversing it.
Can we use any other data structure or no?
What data structure we use?
Stack.
Okay? No.
Can you simply traverse the list?
Mhm.
So you just basically look until like your variable equals null, and then
You can't come back.
You can't come back. Okay, so, and you can't
You
load.
can't come back because it's a single linked list. So once you are here,
Uh-huh.
You can go only
you
for
can't
one
go in this direction. This is a one-way
And you
road.
can't. You say you can or cannot use another data structure.
No. Not directly at least.
All the print function incursively will do it because it will be allocated on the stack and
Okay.
once it's
That is solid. just write print, doesn't matter.
Head dot next. Head dot data.
You have to write print after that.
That one would be after this one, yeah.
Yeah. Actually,
Yes.
yeah, because when
Yeah.
okay, yeah, once it's
Right,
on the
that's
stack, so yeah, print.
Correct.
Yep.
That's it. But non-recursion we can do that.
Non-recursion,
Non-recursion
you have to actually use the stack.
Yeah.
You can push everything in the stack and then start copying. Okay. Good one. Using this, anyone wants to try recursively reversing a list? Anyone wants to try? Come on, it's not that tough.
Oh, the reversal.
Reverse the list recursively. Recursively, we just did iterative. Oh, this was just printing it.
That was printing, not the reversing data. List.
Anyone?
Actually, it's just on single line, right? You call recurse from within recurse to the next one. That's that thing. Just print if you like.
Print? No, you don't have to print it, you have to actually reverse it.
I think
So
this itself will do it.
Okay?
No, we will not do anything.
This is the, you accept the head and then you
Go to the next one
It will
and
be infinite.
then it's in, it
you
will
need a break condition, of course.
Yeah. break it.
On top you say if head equal to, not there, not there. Okay.
Okay. So let's walk through it.
If not of head, so next request me are
One, not head, you're going reverse, okay. 2, 3,
No, it will not work anymore.
Go
Here
till
we are doing
5,
the reverse.
and then you're doing, when it reaches here, it'll just keep popping. There's nothing to do actually.
Right. Actually, after this reverse, we should do some manipulation to reverse it. And we must take a one additional variable as well.
Yep. So, let's start with taking, let's say, result. Now,
This is your break condition. What you do is result equal to recursive reverse node
that's next.
node next. What will we do next?
You have to put result dot next
So-
is equal
Your 1, 2, 3, correct? Your node next is next. So your node next. That is going to start pointing to your node, correct? Node next should be pointing to node, because at the end for this one it will look something like this. Say null. This is your head, correct? So your node next will actually point to node. Make sense?
What if we have a long node?
For now, this is just while we are handling only 3.
Okay.
Because recursion actually takes care of the next ones. So now, when you are looking at your node next, you have fixed. Now you have to fix only your node next, correct? In recursion, always consider only one thing at a time. Leave everything else. Everything else will be taken care of by the recursion. So there are 3 things that need to happen here. One is, actually sorry, 2 things. One is this guy is next, I have to handle. Where will this next be? Null. And somebody has to start pointing to this. Who is that person? So it's the node next. Next is the one who is going to be pointing. So the next guy is supposed to be pointing to me instead of pointing ahead. So it started pointing to me. Now my next has to point somewhere. Has to point to null. So node next equal to everything else will be taken care of by this.
And what the use of result variable?
Because we are going to return it now.
I guess we should add that result dot next into the node, because that's what recursion should work.
So you still need to return, right?
Return what? Return?
Result. Result, right? Result. Does that make sense? Yeah, but does this make sense? Because you are over here. These are the 2 crucial steps that you are handling.
I'm still not like node next equal to null. What like are we not? We will not end up with all node being null. Like I'm trying to understand what that's.
I mean that should happen only if it's a hit. Node
Okay.
next should be null only if
Then
it's
should it be result?
Yeah, I guess that should be something like okay, time dot next result dot next something should be put in node,
Okay.
and then we should return.
Let's start with 1.
Mhm.
So you have a new node result. Is node and node next.
Yeah.
Okay. Both are present.
Right.
So then we'll just come here.
Yeah.
Result is go to node next.
Yeah. And then we'll move
We'll
into
come
down.
here till the time we go till 4.
So there are
At that point in time it will still be correct, and then we'll go to 5. 5 next over here it will just return 5. Correct?
Yeah. Yes.
So now when I
Result
come
is-
here, it has actually returned. So result is 5.
Fine. Yeah. Then we will move to the next node.
Okay. Node next is
That
equal to
means-
node.
Yeah. For to next to next. Oh yes, we are at the back of it.
Yes. So now, what will be node next?
Yes.
What is node right now?
4.
Node is 4. Node next is 5.
Yeah.
Next 5 next is null.
No. Right. Right.
So that should become node.
Yeah.
So your 5 is now pointing to 4.
4. Correct.
No. How can 5 null can point to something?
Wait. This is not 5 null. This is
4.
4.
This is 4.
Correct?
Okay, 4 next is 5.
So 4 next is 5.
And 5 next.
5 next is pointing to null.
Node. Okay. Yeah.
Now, right now, it has started pointing to
So that is result, yeah.
result. So now it is pointing to 4. Correct?
So loop is there. 4 and 5.
Now I am returning result.
Okay.
So what is my result?
So now we are returning
5.
5.
Mm-hmm.
Yep. Yep.
Okay. Okay. So now, when we come back here, we have popped out. So my recursive node next, what will be node at this point in time?
3.
It will be 3.
3.
Correct?
No, hold on.
hold on.
Forget result. Okay. For now, just forget result.
For the first pass,
We'll take result later on. Just forget it. Just concentrate on these 2 steps. We reached 5. 5 next became 4.
Node is 4.
Oh, sorry, this node was 4.
Four.
It be, 4 next. So 5 started pointing to 4.
Right.
4 started pointing to null.
Null.
Correct. So now we have null here. Correct. Okay. Now when we come back, this will be 3.
So why, first of all, node will be 4, node will be 5, right? I mean, you are
At
writing.
that point in time, it has just returned from here. It's a big
Because
condition.
node next is given there in the if
Condition.
condition. So
This
it
is
will
your
terminate
break
before
condition.
1.
That's one thing. So suppose if node came to 4, right?
Yes.
So 4 and
5.
4 dot next 5. So which is valid? So it will still go move.
Yes. It will
So
come
then it
here.
will come to recursive result.
Recursive.
There
It will come here 5 and null. This is false. So it will
yeah.
return 5.
So at that time, what is the node value?
5.
5. So but you are considering in this loop, you are considering as 4.
So when I return,
Mhm.
my result is 5. Correct?
Yes.
For 4.
Yes. Yes.
At that time, node is 4.
result is 5, but node is 4.
Node is 4. Correct?
Yes. Correct.
So then 4 will start pointing to 3. Sorry.
4 will.
4 will start pointing
I
to.
mean 5 will
Null.
start pointing to 4.
4 will start. Sorry. 5 will start pointing
Yeah,
to 4.
right.
4 will start pointing to null.
Yes.
Now when I come back, forget result. This is 3.
Yes.
Okay. We are talking just about 3. 3's next is 4. It's next. 4 next is now
Is
pointing
null.
to 3.
4 next is null. So that is pointing to the 3.
Now 3 is pointing to null.
Right.
Okay.
And
Yeah,
double
yeah.
that
Forget
one.
everything else. Now when we come here, this is I'm talking about 2.
Correct.
3 is still pointing to null. Okay.
Right.
2. 2 next is 3.
2 next 3. 3 next is null.
So now this is pointing here.
Correct.
And 2 is pointing
next
to null.
Yeah.
When I come back here, it will be 1. So 1 next is 2 next. This is going to point to null. 1. And 1 is going to point to null.
Perfect.
And then at the end, when you come out, you will return result. Yeah. Person, you have to take me coffee.
Always get confused with that question. And also if you forget one condition, it will go overflow. That's it.
That first line is required, node star result equal to
So,
is that required?
C++, yeah. Because if you just do node star result, you will initiate a pointer without it having any memory. And when you do this, that's it.
Yes,
One
yes.
exception.
But we are
But
getting
in
the
this
value to
condition,
the
we are
result,
going-
so we need not to.
One question, what's that? One question, sorry, I'll give you an answer in a minute. What?
So see, in the result, we are already taking a reference of the node through the recursion, right? Recursion method. So why we need
Oh,
to
yeah,
assign
actually-
unnecessary value, memory allocation?
Yeah, you were asking?
If the malloc is removed, then my question is
Go on. Okay. Others are still.
Jay, I'm sorry, the return result, again, the last one. So, okay,
You need to return the head, right?
you need to do
The new head.
the new bit.
So in our case, 1, 2, 3, 4, 5, 5 becomes the new head
So,
instead of 1. 1, yeah, 1. So you're returning it. Okay. You are given a linked list. You don't have the head, you don't have the tail, you have just one pointer. And you have to delete that node without destroying the list. How do you do it?
Without having that.
Without head. So if I were to do delete pointer, this becomes null, linked list breaks. So I can't do that. So let's see, what do we have? So we have pointer dot data, pointer and pointer arrow next. If you have pointer arrow next, we have the next one.
Right.
So we have pointer next data and pointer next next. Okay. So if I were to initialize this to this and then get rid of this itself, essentially I have deleted pointer because now, okay, let me give you an example.
Yes.
4, 5, 6, 7. Now instead of 4, if I make this 5 and start pointing it to 6, I have deleted 4, correct?
Yeah.
Okay. So pointer data, actually first we will take temp node star temp equal to pointer next pointer data equal to temp data pointer next to temp next. Correct?
You're not deleting the node, you're deleting.
Yeah, technically I'm deleting the next node, but the linked list still remains as you want it. So you will never do this in production, it's just for the interview. If you ever encounter such a question in production, either you are looking at it wrong, or you can go and talk to somebody and give you a much simpler solution. Okay. How to find a cycle in the node, or rather if the node is, if the linked list is cyclic or not.
So you're looking for repeat values, is that right? Looking for repeat values.
Yes, now you are looking for a repeat value, but you don't know where exactly the value repeats. So what if your node looks like a digit 6? 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's see what's right. Now, what would be the approach that you can come up with? You can start from 0 and then traverse the entire list to see if anybody else is pointing to 0. You go to 1, traverse the entire list. If it was something like this, where there is only one node which is pointing to itself, your worst case scenario will be O of n square. Is there a better solution?
One point more slowly, another
Mhm.
1.5.
Okay. How will that? Why will that work?
So what it will do, like one pointer, past pointer, like the fastest one might meet again slow pointer.
First will be fast next, next, correct? Head next.
Actually, slow will be head next and fast will be head next.
Yeah. Okay. So first let's go through the theory because the code is pretty straightforward. So you have slow and you have fast. Slow starts with 0. This one starts with 2. When it jumps 1, this will jump 2 steps. So 4. This will go to 2. 4 will go to 6. And this will go to 3. This will go to 8. This will go to 4. This will go to 2 again. And at this point in time, this will go to 5. 2 will go to 5. Oh wait. 4. 5 will go to 6 and then this will go to 6.
So I have one question.
Mm-hmm.
You initially discussed that in worst case scenario we will have an n square, right?
Yes.
So we will pick first and then we will iterate.
Then you iterate the whole thing and see if it is pointing to the first one or not.
So when we will terminate the first round?
You will, well,
Because it's an infinite loop.
yes.
So how?
So you'll never infinite.
It's actually not.
So it not be
It will
in
not-
n square.
Well, you can, the only reason why I put that as n square is
Because two loops are.
because if you, let's say you go through 2 loops,
Yeah. Worst
Just wanted
case
to
and
say, yes,
worst
that
case is M infinity.
infinity.
We get yeah.
Then yes, this make sense?
No, we do if condition there, like first loop, second loop.
Right.
So first loop value matches to the second value somewhere, you
Okay.
say breakup.
But it will not, right? You start with 0,
It will go in the loop.
it will never come back, right? It will keep going.
Yeah.
Yeah, I think it's more than just do the two match. I think it's do you have a repeat value?
Yeah. Over here.
Yeah, the other two for loop conditions.
Yeah, so I'll write a code for this and then he will explain one more complication in this when you have to actually find the beginning of the loop. So Boolean is cyclic, node star head again, if not head return false or true, whatever you want, or empty cycle is a cyclic list as well. Yes. Node star has equal to head, node star slope equal to head. So I'm assuming, I'm not sure if the given list linked list is cyclic or not. So I'm making sure that fast and slow actually are not pointing to null. Because it could happen that they have given you a straight linked list. Fast or slow.
Slow will never.
Yeah, slow will
Slow
never.
will never because fast is only 2 times, right?
Still, I will.
Yeah.
And if fast is not equal to slow. So when you come out of this loop, you need to first make sure that fast and or slow are not null. If they are, then you just return false. Otherwise you return true.
And you have not made like fast not equal to null. In case of null, if it is a straight loop.
Yeah. So
If it's not fast, then this is null, right?
No, in while loop,
While fast and slow, and fast not equal to slow.
fast will be null.
If fast is null, then it will come out of the loop.
So wait,
So we actually don't need the slow, right?
Yeah, you don't need to slow.
Yeah, you don't need slow over
So,
here. We
over
don't need
here.
slow over here too.
Right, let me check first.
so this code tells us whether or not there is a loop.
There is a.
Yes.
I thought you said tell me where the loop starts.
I will.
Okay.
Yes.
Even if we assign these two lines and on top before the loop, we will show one iteration.
Yes.
Trying to
Actually, you won't. Your if not head will return.
trying
Yeah,
to access
but
fast
if
next
there is
and
a-
next won't change that throw in there.
Yeah, if there is a next more than
There's a case
two
that
nodes,
there might be
right? More than one node, because
The next
first else
the
if
next
it's
is
written,
null and the next
but
is
if
null.
it is
Okay.
y,
Y
we
is
will
fine.
not
Yeah.
instead of before the loop. Right.
Yes.
At least one iteration we can say.
This will break.
At the next arrow next.
fast not.
Is this okay
next,
to interact
not
this way?
Yeah, it's totally fine. I'm just
No, no,
sorry,
no.
I was distracted by the question.
Ashish,
Yeah,
in the while loop itself, if you write fast dot
Yeah.
next,
Yes,
not null, then we are good.
yeah, we can write that.
Yeah.
There is one condition, but that is, yeah, I think you can fix it in the. Okay, so I will do one more question, and that is more, like the code is very simple, but like the explanation is, it actually took me 3 or 4 times to actually read the problem and then figure out. If somebody asked me this question in the interview, I would not be able to like come out with the thing. But so the question is like, you have to find the starting point of the node, of the loop. Yeah. So,
Of the
of the loop.
Okay.
Yeah, sorry. So I don't know, do you guys know the solution? I don't know. So it is actually a difficult problem. I will make a bigger loop, so bigger loop actually helps. Let's say this is,
Now people will take not time to think. Big loop is bigger.
It's harder now.
it's harder now, okay.
Just kidding.
Okay.
It's like it's the first non-repeated.
First one, we have to find the first one. This one.
Okay.
So 1, 2,
So
3.
the
I
first
don't want to
repeat.
put numbers, but like yeah. So you have to find this one. Okay. So what we will do is we will start similarly with a fast and a slow pointer.
Right.
So fast and a slow. Fast will continue moving. Let's say fast moved and fast reached over here. Okay? And one second. Yeah. So fast moved over here and sorry. I have to think about it again. Yeah.
Right.
So fast and slow both are moving together.
Correct.
At some point of time, slow will actually reach over here.
Correct.
Right? This distance, let's say this distance is k. This distance is k. Okay.
Yes.
Let me think about it. Yes.
So other ways, if like wherever the faster and the slow
Slow
nodes
will
meet,
match.
Yes.
take
Um,
one point over there and
Yes. The explaining part is the bigger thing. I know the solution, but the explaining part is the biggest.
Okay.
So let's say this distance is k distance,
Mm-hmm.
and by the time slow reached over here, k, fast is moving 2 times, so fast has traveled a distance of
K is
2k.
correct.
2k, right?
2K, sorry.
2k. So slow is over here. So fast has traveled a distance of k plus, let's say, another k. So k. So at this point, let's say fast was here. Okay. Let's say the size of this loop was loop. Loop or something. So size of this entire thing was loop. This distance is k. So this distance,
Is loop on this gate.
this distance would be loop minus k. Yes?
Okay, right.
Loop minus
Now,
k.
we don't
K,
know.
K, F traveled to k.
Okay, just for loop.
Yeah.
Okay.
So k
Yeah.
plus k.
Yeah.
So this distance is loop minus k.
You are considering only this loop only, right?
I'm considering this loop right now. So at this point, slow is at the start of the loop. We have to find this element. Fast is at some place,
Right, right.
and this distance is k. Okay. Now what will happen is, depending on how you see it, fast is actually moving 2 steps
Correct.
and slow is moving 1 step. So for fast to actually catch up to slow, it has to, so every time this distance between them is reduced by 1.
Yes.
Yes? Because like fast is moving 2 steps, slow is moving 1 step, So every time the distance between them is getting reduced by 1. So for fast to actually catch up to slow, there will be loop minus k steps. Okay?
Right.
After loop minus k steps, fast will actually catch up to slow. I don't know where they'll meet up, but let's say
Loop minus k divided by 2?
no. So let's say they meet up, they will meet somewhere. Let's say fast and slow meet over here after loop minus k steps, right? Which means slow has traveled
Yeah.
loop minus k steps.
Right.
Yes? So this is loop minus k, the entire is loop. So this distance is k. Yes? Yes. So this distance is k. The point where they meet, the distance from here till here is k. The distance from here to here is k. Right? So what you will do is, at this point, wherever they meet, break the fast or the slow and move it back to the starting of the loop, or starting of the list. And then start moving both of them together, one at a time. This is k, this is k. Wherever they meet, that is the point of intersection. Yes?
So what should the condition you compare the data?
No condition, you don't compare the data, you compare the pointer.
We
Data
lost
though, you can have the entire list as
Yeah.
1, 1, 1, 1, everything can be 1, right? Everything can be the same
So
data.
in C sharp you have to different how we compare pointer?
We are going to compare here nodes.
So
fast
just
and-
comparing two objects, right?
Fast and slow,
I-
and compare the
That's what
object.
I'm just thinking.
C sharp,
I'm just thinking. I mean,
Compare the object.
compare the object.
Compare the objects.
Object or we can
Fast
compare
and
the
slow,
data
you are
as
going to
well.
compare.
Oh,
Both are not equal, then.
Yeah, data can be different. Okay, yes.
Can you repeat that, how you got that loop minus?
I will actually explain it again because it took me like 20-30 minutes to actually understand it. And as you saw, like it,
Even I lost
It-
all video.
yeah, I also, like, it's,
It's kind of sleight of hand thing.
yes.
Loop minus k, loop minus k.
Ashish, you want me to explain?
Sure. Do you want to, is it okay if you want to come on camera?
Yeah, that's okay.
Okay. So he wants to explain.
We will expose
You have to
you.
keep your clothes on though.
Okay, so let's say this is x and this is y. Okay, and we have two pointers. One is slow and other one is fast. So so when slow will move x move, so this is full is x and this is y. So if x slow, when we start from here, when it will travel x pointer,
Okay.
where can you tell me when, where it will complete the x nodes,
X minus Y.
x minus y, so that will be something here,
Yeah, maybe.
and where the fast will end up at that time,
Simply. So
2x
X minus Y into
2x.
yeah 2X.
So
2X.
So 2x will be 1x will be like this, and again fast will end up with here. So if you are talking about fast, so first x will end up here, okay, and again x, again it will end up here. Understood?
Yes.
Got the point or not?
no, basically whatever the loop size is n minus k, so it travels that much time, slow pointer, and that's just a double is fast pointer. Simple.
No, simply x will reach here, okay, and in
Okay.
slow will reach here in x move. So and fast will move. First round is x, and second round again it will end up here. Simply.
Generally they say it will, like in book they I guess given the n minus k where they are saying n is total number of nodes and k is the node where, so they say n minus k slow pointer and 2n minus 2.
Okay.
I mean,
I did not understand like that, but I
Uh,
understood
let-
it the other way.
let me explain
I got it,
Yeah.
I got it. So slow, wherever they meet, slow has moved some x distance.
Yeah,
Fast
slow will
will
move
move
x
2x.
distance, fast will move 2x.
2x.
So slow, once it will, what is x? So this
But
is,
how do you
this is
know?
x.
How do you know? No, no.
This
no,
is
no.
x.
How do you know slow has moved x? Oh, after
When
after.
slow will move x, fast will move 2x. That is what I am trying to say.
Oh, okay.
So when slow will complete x, let's say if it is here, what fast will do is 2x.
2x.
So fast 1x is this and 2x,
2x
is
is
again.
this. Sure, sure.
Simply.
Okay, so they meet at this point.
Yeah.
But that's not the point we want.
Yeah.
We want the meeting
Yeah.
point.
So at this point, we are at the same distance. This is y.
Yeah, that is the explanation of why you have to tell them.
Yeah. So how much x has traveled? X. So suppose we have traveled x nodes. So what is x? X is like this is already traveled y. So it is x minus y.
Okay.
One more thing. How would we
No,
calculate the
this
x?
This is x minus y.
This is
and
x.
This is y.
Because
Yeah,
x
we
is
don't know
already
x.
traveled y distance.
But we don't know x, right? How
Yeah,
is x?
We do. We can tell x
we
is when
don't
they
know.
meet. Right? So x is when they meet.
No,
X
we
minus
initially
y.
don't know.
No,
No.
we
Right.
we don't know. This is x, but
Solve for it.
when slow will come here, it will move. Suppose slow has moved x distance. So what is x? X is this. This is x plus he has already traveled y.
Again,
So this is
I mean,
x minus y.
I mean, it's a little confusing here. That's okay, but how do the distance is equal?
Yeah, that is what I am trying to make to understand that this distance will be this thing.
So that means it's 2n minus 2c.
Now it's like.
It's like the parliament.
How do you know this is the white? You have seen the.
Let me tell you. This is
Now you know why.
Okay.
The thing is, actually they want to understand like
When you reach the x, how do you know the distance
Doesn't
is
contain
from
the
that point
mixture
to the
with
second
the-
point to the
Okay,
point?
let's
X
start.
that equals to.
So I have traveled x distance now.
This one मेरे को भी नहीं समझ आ रहा है what was happening कि जैसे x अगर ये पूरा distance x हो गया this distance is
This distance is x. Yes. Yeah.
थोड़ा धीरे चलो ये distance ये y है ठीक है अभी they meet at some place right so fast and slow meet at the same place wherever they meet at that time like let's say if slow was at this place slow was here and fast was anywhere over here both of them traveled and they met at some point right so that some point is you have to find you have to say that some point is x minus y you have to explain that part because
But
now
this is one way of making them understand.
Sure.
What I am trying to understand, like this is, let's say, if these are x number of nodes.
So yeah, the second thing that you said that slow will actually come and meet at this place. At that time, slow would have traveled how much? Y plus this much distance.
What's x?
Yes. X.
And y plus
X.
loop minus
Oh,
y.
wait, I'm sorry.
No,
Not
it
in
has
your
only
definition
X.
of x, not in yours.
It has traveled x nodes.
okay.
How will you calculate x
It will be
node?
X.
X node is this, and when this is y and this is x. This full is x. So when we say x has traveled, slow pointer has traveled x nodes, so it will end up just before
Just y.
Just
nodes-
before-
y nodes before.
y nodes before the meeting point.
Meeting point. Okay. Okay.
So that is what I am trying to like.
Sure.
Yeah. If and at the same point, the fast will move one. This is 1x,
At the same
and second time this is 2x.
Sure.
So this is the point where this will be always
Y.
y distance from the meeting
From
point.
this, and then we can do it.
Yeah.
Yeah. So like he said that is the second approach.
Yeah.
He said that he wants to understand the first
Okay,
approach.
okay.
I will do the first approach again because that is I get your point like what you're trying to. It's basically the same thing.
Yeah.
Basically. Thank you. Okay. So I don't do. I have memorized it, so I don't use X and Y. I don't use X and Y. You will do K. If somebody asks me this question in interview, I am not that genius that I can do it. Okay, let's say this is k distance. Some point x slow will reach the k distance. At that point, fast will be somewhere here, and this distance would be k, because fast is traveling 2 times. Okay. This whole thing is loop, so this distance is loop minus k. Okay. Now fast is moving 2 times, slow is moving 1 time. So for every time the distance between fast and slow is getting shorter by 1. So in loop minus k steps, fast and slow will actually meet, because this distance between them is loop minus k. So which means that wherever they meet, I don't know where they will meet, but wherever they meet, somewhere here, slow would have moved loop minus k steps. If this is loop minus k, this will be k. Right? This is loop minus k, this is k. Both of them have met, and now slow, move either slow or fast over there, and then move 1 by 1, and then you will reach over there. I will send the code, and that is basically exactly the same thing that we have done. Next class, like these are the things we do. Merge sort.
Saturday.
Saturday, yeah.
Saturday what time?
Saturday 10 to 12. Yeah. So merge sort, even elements are placed on the start and the odd are placed at the end of the list. So basically it will be a list, and then you place all the even on one side or odd on the other side. Find if it is a palindrome. Retain m, delete n. I will send the list, don't worry about it.
Okay.
Retain m, delete n, reverse every k elements. To list, figure out where they are merging, and zip merge. Zip merge would be something like.
So you mean merge sort and linked list?
Yeah. Okay. Yeah. So zip merge would be something like 1, 2, 3, 4, 5. So you break this, and then you take 1 and 5, 2 and 3 and 4. Right. So one from the start, one from the end. Then add to linked list. So let's say a linked list is.
Can you tell me this one? 1, 5, 2, 4 and 3.
Yeah. Let's say.
And what is this? Merge, zip?
Zip merge.
Zip merge.
Yeah, like zip. You.
Okay.
So 1, 2, 3.
Oh yes.
5.
So we will.
No. So what we will do is this list will become 1, 5, and then 2, and then 3. And
2 and 3, 4.
2 and 4.
Yeah.
And then 3.
Yeah.
Okay.
So we are considering that the first linked list is the open zip,
Yes.
and we are closing.
Closing that. So adding to sorted merge, 2 lists are sorted, and you are merging them, and the merging is sorted. Add to linked list is the question like 1, 2, 4 is there, and then 2, 3, 6 is there. Then you have to add like an addition.
Oh,
Or
node by node.
Node by node. And then removing duplicates, and a Dutch frag problem, which is similar to that, the one which we discussed in the arrays. But Dutch flag is basically similar to even on this side or on this side. And the random pointer copying. Random pointer copying is also a question which is, somebody asks me to do it, I cannot do it.
What is the question?
The question is like every list has one link, and then there is another link which is pointing randomly to something else, and like this. So now
So this is doubly linked list.
no. This is not doubly linked. One is pointing to the first one. Second is a randomly pointing to any of them.
So this is not a linked list.
This is a kind of a linked list. Now what you have to do is you have to create an exact copy of this linked list. Try it. It's actually difficult if you have not tried
Exact
it.
copy without link.
So how?
Without random link.
So you have to
No,
create
with
a new
random link.
list. 1, 2, 3.
Without random link, right?
With random link.
With
random link
with
is
random link. Without random link, you just go to like.
No, even with random link also we can go to from 1 to 2. I can go to 2 to 5.
Well, try it. It is actually difficult. The solution is there. There are people who are
This link is for now 2 pointers, right?
Yeah.
Each node in your.
Yeah, how one node can hold 2 pointers?
Yeah.
So we will define the
Structure is
separate
different.
pointers. One is pointer next, one is random pointer.
Oh, you will have a 2 pointer. as a
We'll change
change.
it.
How they define.
Otherwise,
my friend.
oh, you got it, got it.
Very quite attractive.
Oh, okay. Now through the structure it's clear.
Yeah, I will send you.
Here's your technique.
Yeah.
Let's
understand
Thank you.
Yeah. I think.
Thanks, Dave. Thank you.
So 10 o'clock Saturday.
Yeah, appreciate it.
वो स्ट्रिंग वाला वही भेजना।
यार मेरा बहुत